Good morning. I'm Jim Carefoot with Armada Technologies, and welcome to our Friday webinar, Find It, Fix It. Today we're doing, as we sometimes do, take requests from people to cover a topic. We're covering our automatic multimeters with clamp meter functions on them, and we're going to talk a little bit about meters and about what these do particularly and what we as a company have to offer and how you use them. So we are going to get started here. Hopefully everyone can see me. Everyone is muted on this conference, and we are taking questions using the message panel on the right if you like to, or you can email me at jcarefoot@armadatech.com, which I'll show again at the end so that everyone can see it. The things we're talking about today are automatic clamp meters. We have a couple of models that we sell and other folks sell, and we use them pretty commonly in the green industry for different things. We're going to today just talk about, as you can see on the slide, what we use the meters for, the kind of meters that are available, what these ones are all about, and how to use the automatic clamp meters in green industry applications, including lighting and irrigation. The photograph here shows the Pro90 in use. Someone is using it to measure the amount of power being delivered to a lighting string from a transformer unit. It's a very common way of determining how well loaded the system is and using the clamp function. When you're using the clamp function, you don't need the test leads attached to it, which in that photo was the case. There was no test lead connected. So talking about electricity and water, most of our customers in green industry are water people. They're not electrical people, so we took a little bit of time to talk about the basics. In this case, we're talking about electricity versus water. A lot of similarities, interestingly. In a water system, you have a head of water represented by a reservoir full of gallons and a pipe delivering it down into a field location under pressure, and water flows and into openings down the pipe and delivers some number of gallons of water at the far end based on the pressure and flow in the pipe. Electricity is very similar. We've got a stack of stuff in the form of watts and an electrical power source, like a lighting transformer, and we deliver that power down the pipe, which in this case is a pair of wires. The pressure is equal to voltage, and the flow is equal to current in milliamperes, and we're delivering watts. So instead of pounds per square inch producing gallons per minute, reducing gallons into the field, we're using voltage to generate amps that delivers watts. Kind of really very similar, but not really too mysterious. There's a lot of analogies between the two of them, and this just shows in a simple equivalent. Current in amperes and electrical amperes is the same as a flow in a pipe. The voltage is equal to the pressure. In electrical systems, we need to have voltage producing a current in order to develop power, deliver service to the field. Electrical resistance, the equivalent to that is resistance to flow in a pipe. If the pipe's big enough, there isn't very much resistance. We can deliver a lot of water, deliver a lot of energy. Voltamps or watts is a common way of rating a system, especially in lighting, where the amount of power that's delivered is the key design factor. It delivers lumens, and you have a transformer rated at a certain level. So that's a good application for clamp meters, as you'll see. Whether you even need an electrical meter in the first place is one of the questions we ask. In our industry, we really need an electrical meter of some kind, even a basic one. And what I show on this little table here is one of our most basic meters, the Pro90, and we have a little cheat card for it because it's an inexpensive meter. It's kind of complicated to use. Doesn't have the single butt features of our automatic meters. But it's their little cheat card that we give out with it is a good test of whether you need a meter. And in this case, the 5 most common things you do in an irrigation system that you need a meter for: checking the voltage at the output of the clock, checking the resistance of a solenoid to find out if it's good, checking your AC power outlet, make sure the voltage is there for driving the controller and clock, even checking fuses. I usually say if a fuse looks like it's good, don't trust it. Always ohm it out, and a simple electrical multimeter will allow you to check to make sure the fuse is actually 0 ohms and didn't blow in a way that you can't see, which sometimes happens. So in the end, we're using an electrical meter to tell us some real physical world stuff. In some ways, we don't even care whether it's 24 volts or 12 volts or something else. It's there to tell us whether the system's healthy. And in the top block there, we're using this meter to determine, number one, if our system has power, is delivering the power downstream to whether they're solenoids on automatic valves or whether they're lighting systems, and determine if the systems that downstream from the controller are working. All these things are what we're really after. What we have to do then is take what the meter is telling us and convert it into those real world things. And so down below you can see what we actually read with the meter is volts, voltage in volts. Using the test leads, we measure resistance in ohms, and using the test leads, and then we can put the clamp around a wire and we can measure the current in amperes. Now those things all by themselves aren't really useful until you know what the importance is or what the range of those readings actually means to you when you're trying to troubleshoot or check your system. And I'll go through a little list of those things here in a second. The things we're using today are examples from the Armada product line. We have a line of meters, and these two automatic clamp meters are in the middle of the line and offer some real benefits. The Pro90 is an automatic clamp meter, single button control, and an averaging type meter, and the one on the right, the Pro91, is a true RMS meter, clamp meter, very similar to the 90, except that it has that computing power of true RMS built into it, and it's necessary for certain kinds of systems like LED lighting, as you'll see. So meters and the data sheets and information on these meters you can get from our armadatech.com website. So I'm not going to talk a lot about detailed specs, but just about applications and the nature of the specs. These two meters are in the middle of our line, as I said, and they're targeted for one general purpose use in green systems, irrigation and lighting. The Pro91 in particular is targeted at lighting systems that are migrated to LED because there's a little different measuring technique required there. We have a fancier, more expensive meter that's very sensitive, that's used in two-wire irrigation systems and some lighting systems. That's on the top right, and the lower left is our inexpensive pocket meter, the Pro30, kind of a $20 item, but very useful for a lot of things you do, but some things clamp meters can't be replaced with. So what is an automatic clamp meter? An automatic clamp meter is basically an electrical multimeter to begin with. And a multimeter, we mean by that a device that can measure both electrical resistance, electrical current, and circuit resistance, or current, voltage, and ohms. So those things are fundamental to multimeters. In this case, we have a single button control, so it's automatically switching between kinds of modes and measurement techniques. That buys us simplicity and ease of use, and we can measure current by clamping around wires instead of interrupting the circuit. In classical electrical systems, a lot of times you have to interrupt the circuit and insert an ammeter to make a check on that. That can be not only hazardous, but it's complicated. So what we've done here is we've got a clamp over way of checking current. We can read all the current, voltage, and resistance stuff we need, and it's got one button control, so you don't need to be an electronic wizard to use it. Simplicity and ease of use are the keys with the automatic multimeters, and they're well suited to the techniques that we have to have for green industry. This little blurb here that shows you something about how automatic works is out of the manual, and I'm not going to go through it in great detail, but it sort of in a way explains what you commonly see on the screen when you first turn on one of these meters. The meter is constantly looking to see what it feels on its connected leads and in the clamp, and depending on what it feels from those different circuits, it switches modes. And if the meter is just there with nothing connected to the leads and no clamp around a wire or anything, it switches back to resistance and just kind of sits and waits. And that's where the screen, the OL, comes from. You'll see the OL on the meter screen, and it means over limit. That's all it stands for. It means that the resistance is huge and it's too big to measure, so it's just waiting. If you were to connect it then to a voltage or an AC/DC voltage, hook it up to a battery, immediately it smells that presence of that voltage and it switches over depending on the type it finds. So the OL is the screen you see when this thing is idle, whether leads are connected or not, but when the lead's not connected to a circuit. The parts of the meter, pretty compact device. A lot of times I handle it without the leads connected to it because they're unpluggable, of course. If you're using a clamp, you don't need to connect the leads. But for most functions, voltage and resistance, the most commonly used things, you do need to have the leads, and the probe leads are used to touch the circuits that you're getting into. I've got a little video that shows a simple measurement with this type of meter in just a moment. The current clamp's at the top. It's got a lever that you activate it with. You squeeze the lever, the clamp, the jaws open. You put it around a wire and then let the jaws close back up again so the wire is going through the gap in the middle. And when you're doing that and there's a current flowing, the meter automatically switches over, smells the current, and shows you how much current is flowing. This is an AC current in the case of the Pro90 and AC or DC in the case of the Pro91. And in the case of the Pro91, where it smells DC, an interesting application could be solar panels. If people are doing that, that's a thing that comes with that meter. The digital display is very simple, very straightforward, easy to read. It's got an automatic backlight. When the lights get dim, it automatically kicks on the backlight so that you don't have to mess around with trying to make it readable in dim light. So the control button is the real key to this thing. The ease of use, the automatic, other part of the automatic aspect of this is when you hold that button down and kick it off, it goes in and checks its battery state and switches to whatever measurement you're going to be doing, and it changes on the fly. So as you move the probe and the clamp around, it'll automatically switch back and forth. You can stick the probes right into the outlet in the wall and measure 120 volts and go over and put them across a solenoid and measure 60 ohms, then the thing will just switch right over. Really very straightforward to people who aren't interested in some of the details of the electricity. So and one point about the clamp meters is if you're measuring current, you can't clamp around the entire cable in the system you're working with. For example, if you've got a heavy 12-gauge cord going out to the field for a lighting system, you need to split the cord apart and measure the current in one wire. So you clamp over one wire and read it that way. If you clamp over the whole thing, you won't read. You'll read zero current. Won't be accurate. So next we have the kinds of electrical meters or electrical systems we're working with are very low voltage, and the voltages are not hazard. They aren't going to cause a fire. They aren't going to hurt anyone. So the voltages we're dealing with are 24 volts AC, and resistances are on the order of 60 ohms, and a quarter of an amp type of currents. Very, very small things. The only things that are hazardous here are 120 volts AC. So that's the only place that caution is really required. When you're dealing with electrical systems, the voltage is even lower, 12 to 18 volts, and 10 amps AC is common in a system, much larger current, easily measured with a clamp. The Pro90 can measure if you have an incandescent lighting system, the Pro90 does a good, accurate job of measuring the amount of power being delivered downstream. In an LED system, you really need to use a Pro91. So we have, to the next slide here, back to this thing about interpreting what the meter tells us. We have to make some real-world conclusions based on numbers coming out of the system. The resistance readings, for example, that are shown here have real-world meanings. If the resistance is very low and it's zero, you've got a short circuit. What we're interested in really is whether we've got a short circuit, an open circuit, or we have a normal solenoid, and we have go in and read the resistance, and that resistance tells us the things that we need, leads us to that conclusion. Same thing with voltages. I want to know if the voltage is normal. We're supplying power to the field. If it's reading 24 to 36 volts on the meter, that's what that means. I don't care almost what the number is. I just know that 24 to 30 volts is normal, and that means the clock normal output is normal. So I'm going to play a little bit of a YouTube video here to give you a demonstration of a very simple use of the Pro90, and I'm going to switch applications to do that and audio, so bear with me a moment.
Now I want to check the clock output to make sure that that's good. So on zone 1, we've activated the zone 1 using the clock, using the manual controls. And if the clock is working properly, we should see 24 volts at that station. So I'm going to put my leads first on the common wire and second on station 1. And I should get 24 volts or somewhere similar to it. Here I'm getting 26 plus. So that output is correct at that zone.
Okay, I hope you were able to see that. Very short little demonstration of the way the test leads are used to make a simple measurement in a clock and an irrigation controller system. Didn't have to set for voltage or AC or DC or any of that sort of stuff. I just took my leads and touched it to the unit. It's a good place to mention that we have 20 plus demo and training videos available at our YouTube channel. Our YouTube channel is at youtube.com/user/Omatotech. So pretty easy to find, and you can link to it even through Facebook. But Why do we have two different clamp meters? The Pro90 is the fundamental simple meter that we sell. It does all the things that you need to do for most multimeters. It has volts, ohms, and ampere measurement capability. It has simple control. The ease of usability and simplicity are a main issue here, especially for people that are not electrical people. Auto ranging scale for the same reason. Auto sensing measures AC amps through the clamp. Great thing for lighting systems as long as they're incandescent type systems. You can measure the power. You can measure the power in household electrical circuits for that matter, as long as you can get around the wire. But in the case of the Pro91, you see the feature set has expanded a little bit, and we're able to use the Pro91 in LED lighting systems where true RMS features are required. True RMS is a term that's pretty geeky. It stands for the root of the mean squared, RMS. What it really means is that this meter is computing, and no matter what kind of waveform and off and on sequence is going on in the lighting system, it will measure accurately. And in LED systems, that's very important because the current is not linear, and it needs to be measured a little differently. This also measures DC amps through the clamp meter. The place I would see that as having some extra benefit is in solar powering systems where the feed from the solar panel is solid AC. Solid DC, and you need to measure that before it gets to the inverter. So meters can cost a range all the way from down to 20 meters, a little pocket meter, to up $400 is not hard to spend on a meter. These two meters are between $100 and $200. They're our professional grade automatic clamp meters. So here's an example of using the Pro91 in a lighting system. If you've got an LED system, we've chosen a Pro91 here because it's true RMS and clamped around the output lead, one of the output leads going to the field string, and measuring, allowing the current to sit. It takes a little bit. The computing meter settles down after a few seconds. You clamp it on and let it sit for a little bit and get a final reading, and that is the true power. So you can take 12 volts, if you use your voltmeter, check to see how much voltage there is, typically around 12 or 13 volts, and then the amount of current you read on the screen there, and multiply the two together, and that's the true wattage that's being provided to the field. Big benefit of the true RMS meter is you can do that simple math, and it'll tell you what the real watts are being delivered. An averaging meter will tell you a low number. It'll tell you that less watts than you're actually consuming in the field. So, interest of keeping this short. Next week, we're going to cover the differences in troubleshooting between two-wire systems and conventional irrigation systems. Two-wire systems have a very different method of controlling and distributing power, and the tools are required a little different, although many are in common. So we talk about the difference, what's good, what can be used in both kinds of systems, and what special tools you might need in two-wire. Here's our resource stuff for the internet. It is going to be up there with the recording of this session. It'll be on YouTube. Our various ways of contacting us. My email address is at the bottom. If you have questions, you can send me an email at jcarefoote@armadatech.com. And our blog site is armadaupdate.wordpress.com. At that, we use that to download links and application notes and diagrams that are not in the data sheets and things. So Facebook link to help find us primarily. The YouTube I mentioned earlier at Armada Tech channel, and armadatech.com is our main website. You can get data sheets, you can download information on the products there, and you can link to some of the training videos that are on YouTube as well. So that's all we're going to cover today. You're welcome to email me some questions if you have some, and we will respond to those. And we hope to see you next week when we're covering the two-wire versus conventional irrigation. So thanks for coming.